All right, listener name. You ready to dive deep? Today, we're going to unlock the secrets of FBARs.
FBARs.
Those tiny titans powering our smartphones and wireless networks.
Yeah.
You sent over some seriously cool technical documentation on film bulk acoustic resonators. And trust me, this technology is way more fascinating than the name might suggest.
I have to agree with you there.
Right.
It's not every day we get to explore something so fundamental to modern tech,
Yeah,
yet still shrouded in a bit of mystery.
exactly. And honestly, when I saw piezoelectric in the document,
Yeah.
I felt a little geeky thrill.
Yeah.
It's like something out of Star Trek, wouldn't you say? What exactly does it mean in this context?
It definitely has that sci-fi ring to it, doesn't it? But this
Yeah.
is pure science fact, and the implications are huge. Piezoelectricity in the case of FBARs means we're talking about materials that vibrate
Uh-huh.
at incredibly specific frequencies when stimulated by an electrical signal.
Okay, so let's unpack that a bit.
Sure.
So these tiny films are actually vibrating thousands, even millions of times per second.
Billions, actually.
Billions, wow.
And those vibrations are the key.
Okay,
Think of it like this. Each FBAR is a gatekeeper carefully selecting which frequencies get through
okay.
and which ones get blocked.
And that's how they filter out unwanted signals.
Precisely.
Wow.
It's like having a microscopic bouncer for your phone's antenna, only letting in the important stuff.
I like that analogy.
The document mentioned that FBAR filters have a steeper rejection curve than those older SAW filters.
Right.
Now that's where things get really interesting.
I was hoping you'd explain that. It sounds important, but a steeper curve was the big deal.
Imagine trying to have a conversation in a crowded room versus a soundproof booth.
Okay.
That steeper rejection curve means FBARs are like those high-end noise-canceling headphones.
Ah.
They're incredibly good at isolating the exact frequencies they're designed for and rejecting everything else, which is crucial for today's wireless networks.
Which brings us to 5G.
Yes.
The document kept highlighting how essential FBARs are for 5G technology. What's the connection there?
5G is all about speed and capacity, right?
Right.
But to achieve that, it relies on much higher frequencies than previous generations.
Okay.
Think of it like this. Higher frequency signals are like race cars fast,
Uh-huh.
but less stable, prone to interference.
So we need those super selective bouncers to keep things running smoothly?
Exactly. Older filter types, like those SAW filters we mentioned, just can't keep up.
Right.
They're not precise or fast enough to handle the demands of 5G. FBARs, on the other hand, are designed to thrive in that high-frequency environment, making them absolutely essential for 5G to work as promised.
This is making me appreciate my smartphone on a whole new level.
Yeah.
Speaking of design, I noticed the document mentioned a freestanding FBAR structure.
Yes.
Honestly, it sounds a bit precarious. Is it literally just hanging in there?
It does sound a bit unnerving, doesn't it? Picture a tiny bridge with the piezoelectric film suspended in the middle.
So it's not going to fall apart if I shake my phone too hard?
Not at all. This freestanding design, while it sounds delicate, is meticulously engineered. By minimizing contact with other materials, energy loss is reduced, making these tiny resonators incredibly efficient.
Okay, that makes sense. It's amazing how much thought goes into something so small. Like, the more I learn about FBARs, the more impressed I am.
And we've only just scratched the surface.
Oh, really?
This tiny technology has applications that extend far beyond smartphones and 5G.
Okay.
Did you know they're also used in speakers and microphones?
Wait, really?
Yeah.
That's wild.
Yeah.
It's like they're this hidden ingredient in so much of our tech.
Right.
But how does that even work? I thought those used completely different mechanisms.
You're right. Speakers and microphones seem like a world away from filtering radio signals.
Right.
But that's the remarkable thing about FBARs. The core principle remains the same. It all comes back to piezoelectricity, that ability to convert between mechanical vibrations and electrical signals.
So with a speaker, instead of just filtering an existing signal, the FBAR is actually creating the vibrations that become sound.
Exactly.
Wow.
An electrical signal causes the piezoelectric film to vibrate, generating those precise sound waves. And in a microphone, it works in reverse, converting those incoming sound waves into electrical signals.
Okay.
It's the same fundamental principle, just applied in ingenious ways.
That's just mind-blowing. Okay, so we've covered how FBARs are crucial for our smartphones, enabling lightning-fast 5G, and even shaping the sounds we hear every day.
Right.
It's already a pretty impressive resume.
It is.
What's next for this tiny tech?
The document hinted at some seriously futuristic stuff.
Well, what's exciting is that we're only just beginning to tap into the potential of FBARs.
Okay.
Right now, they're mainly known for communication.
But researchers are exploring applications that could revolutionize everything from healthcare to environmental monitoring.
The document mentioned something about ultra-sensitive sensors.
Yes.
What kind of things could they detect?
We're talking about sensors that could detect the slightest changes in pressure, temperature, even the presence of specific molecules. Imagine a world where we could monitor air pollution in real time.
Wow.
With unprecedented accuracy using FBAR-based sensors so sensitive they could detect a single pollutant particle.
That would be game-changing, especially with growing concerns about air quality.
Absolutely. And it doesn't stop there. In healthcare, imagine FBAR-based implants that continuously monitor a patient's vital signs, detecting subtle changes that can indicate a problem long before any outward symptoms appear.
Okay, now that's straight out of science fiction, but in a good way. And what about the medical imaging applications mentioned in the document?
Yeah.
Could FBARs change the way we see inside the human body?
They very well could. Because FBARs can operate at such high frequencies, researchers are exploring their use in developing a new generation of ultrasound devices.
Yeah.
Imagine ultrasound images with detail so sharp doctors could diagnose conditions earlier and with greater accuracy than ever before.
It seems like we're on the cusp of some major breakthroughs thanks to this tiny tech.
I think so.
I was particularly intrigued by the document's mention of combining multiple FBARs. It hinted at even greater precision and functionality.
Yes. That's where things get really exciting.
Okay.
Think of it this way. A single FBAR is impressive.
Right.
But imagine an entire array of these microscopic resonators, each one tuned to a slightly different frequency or designed to respond to a specific stimulus.
So by combining them in different configurations, we could create a system that's greater than the sum of its parts.
Precisely. If a single FBAR can precisely filter a signal or detect a change in pressure, imagine what an orchestrated network of them could achieve. We could be talking about processing vast amounts of data simultaneously with incredible speed and accuracy.
What kind of applications would that open up?
The possibilities are vast. We could see breakthroughs in advanced communication systems, high-performance computing, even quantum information processing. Imagine a world where complex calculations that currently take days are completed in fractions of a second, all thanks to the power of FBAR arrays.
It's mind-blowing to think we could be on the verge of such a technological leap, and it all stems from these tiny resonators.
It's a testament to the power of miniaturization and the ingenuity of those who design these intricate systems. And to think this is just the beginning. As we delve deeper into the possibilities of FBAR technology, who knows what incredible breakthroughs await.
It really makes you wonder what the future holds.
Yeah.
So, listener name, if a single FBAR can achieve such remarkable feats of filtering, sensing, and even shaping sound, imagine the possibilities when an entire ensemble of them are working in perfect harmony.
The potential is truly limitless. And the most exciting part is that we're just starting to explore these possibilities.
It seems like we've only just scratched the surface of what FBAR technology can do. Thanks for joining us on this deep dive. Until next time.